Am I audible to you all? ओके तो कल लास्ट क्लास में हम लोगों ने पढ़ा था फंक्शन जनरेटर के बारे में और ठीक है लेट अस रिकैप समथिंग अबाउट द ऑसिलोस्कोप एंड वी विल स्टडी टुडे द स्पेशल टाइप ऑफ ऑसिलोस्कोप स्पेशल ऑसिलोस्कोप्स एंड प्रोब्स डिफरेंट टाइप ऑफ द प्रोब्स जो ऑसिलोस्कोप्स में यूज होती हैं उस प्रोब्स के बारे में हम थोड़ा सा पढ़ लेते हैं इन टुडेज क्लास that is the thing which I have already told you about the oscilloscope. That is the introduction and basic principle that we have discussed already. You may take a screenshot. I will share this slide also. No issue on the Google Classroom. So this is the CRT diagram which we have already discussed, and this diagram basically consists of all the voltages applied. So just I am focusing this CRT. As you can see, these are the backside pins available, and there is a cathode is available, cold cathode is there, and there is a control grid. So cathode basically emit the electrons, and the control grid controls the intensity of the electrons, how many electrons have to be passed from it. And you can see the negative voltage is applied on the control grid at the top side. After that you can see there is a focusing anode, right, and accelerating anode you can see, and pre-accelerating anode. There are three anodes are given here: pre-accelerating anode, focusing anode, and accelerating anode. All three type of the anodes together works as a electrostatic lens. They focus the electron beam on the center of the screen. Some of the electron, when they pass through the control grid basically consists of some small hole. So when the electron comes out through the small hole of control grid, some of the electron diverge in different direction. So this for this anode combination of three anode, that is accelerating anode, pre-accelerating anode, and focusing anode, they all together works as a electrostatic lens. They form a electrostatic lens here, and they converge the electrons which are diverging from their direction to a center point of the screen. जो इलेक्ट्रॉन इधर उधर भटक रहे हैं उनको वो फोकस कर देता है इलेक्ट्रोस्टैटिक लेंस टू द सेंटर ऑफ द स्क्रीन. And you can see that there is a voltages are applied, very high voltages are applied on the accelerating anodes. 400 volt, 10 kilovolt is applied on the accelerating anodes. And after that you can see the deflecting plates. The first is the vertical deflection plate, and the second is your horizontal deflection plate, which is near to the screen. And the applied signal is applied is given the is a applied signal is on a vertical deflection plate, which we want to present on the screen. That is applied on vertical deflection plate, and sweep voltage or sweep signal is applied on the horizontal deflection plate, right? So this is the complete block diagram of the of the CRT, you can see. And further in this slide you can take a screenshot, the explanation of all the parts of this electron gun, deflection system, fluorescent screen, and then phosphor screen characteristics. These are basically written here, represented here, so you can go through this text and you can understand in a better way. I'll share these slides, Dr. Later on. This is the phosphor screen characteristics of the. Next is your block diagram of simple oscilloscope that we have already discussed. So this is the block diagram or simple oscilloscope. Vertical amplifier, we can see time based trigger circuit, horizontal amplifier, that we have already discussed. Next is the that we have already discussed. This also we have seen. Trigger circuit we have seen. Now there is another concept of oscilloscope, probes. So probes are basically used to measure the voltage and currents from the oscilloscope. और probe जो है different type of the probes are available for the oscilloscope, that is, and whose input impedance is the 1 mega ohm. तो probes का जो generally input impedance होता है वो 1 mega ohm होता है, तो we have to select the 1 mega ohm in the oscilloscope, then we can connect the probe to the oscilloscope. So there are different type of the probes also. There is a high voltage probes, current probes, and there is a one more, that is the coaxial is also connected into the oscilloscope. The coaxial cable have the impedance of the 50 ohm. So we have to select the 50 ohm from the front panel of the oscilloscope to connect that probe. So oscilloscopes are widely used for the test and the repair of the electronic instruments equipment for all type. However, it is necessary to have the method of connecting. So this is the text which is written in a very simple form. You can go through this and you can understand in a better way. So let us discuss there are the different type of the probes are available. This is the text. You can see the same thing which I have told you, that the probes have the impedance of the 1 mega ohm. They also have the X1 into X10 probes. There is a switch is available on the probe. The X1 is written into one X1 and X10 is written over the probes. That tells you ki whatever signal you are going to measure through the oscilloscope, the probe will amplify that signal. So if it is mentioned as the into 10, so the signal will be you can go through this. You can understand this. The most common type of the probe with the built-in attenuator gives an attenuation of the 10, and it is known as the into 10 oscilloscope probe. So when the into 10 पे अगर आप switch को आप select कर लेंगे तो signal will be attenuated by the 10 times. If 10 volts you are measuring and selection आपने 10 पे किया हुआ है into 10 पे, यानी X10 पे selection किया हुआ है, तो that signal will be represented as 1 volt on the face of the screen of the CRO. So, and if it is selected as a X1, it means no attenuation is applied. Whatever voltage you are going to measure, the same voltage will appear on the screen of the CRO screen. So CRO screen. So that is very important. Whatever selection you have made on the probe, the same selection should be done on the oscilloscope also, into 10 or into 1. That is already given on the front panel of the oscilloscope. वहां पे दिया हुआ होता है, और दैट सिलेक्शन यू हैव टू मेक कि वेदर वो प्रोब जो है मेजर कर रहे हो वो X10 पे सिलेक्टेड है, X1 पे सिलेक्टेड है. दैट इज वेरी इंपॉर्टेंट. ओके, नाउ that is the 10x probes uses a series resistors. Basically attenuation जो होता है वो resistance के through ही होता है, and input impedance is 1 mega ohm as I told you. So this is the diagram for the probe. You can see this is the compensation equivalent circuit is written here. That is the coaxial cable we are using, and you can see, you can expand this, and there is the cable, and there is a resistance is connected through this. The combination of the resistance is in the parallel and in the series with the capacitor. The capacitor के parallel में वो resistance को लगाते हैं. That is the 1 mega ohm resistance we are using here. Okay, so this is the compensation, and through this capacitor we are varying the impedance of the impedance is generally fixed for the probe. That is the 1 mega ohm. It is not varied, and it is taken as a constant. So, but compensation we do with the variable capacitor. Compensation means compensation means कि if there is a offset is available in the probe, then we can compensate through this the capacitor, that is a variable capacitor. So that is used for the compensation purpose. So for many probes, many scope probes, there is a single adjustment to provide the probe compensation, although there can be two or two on some probes. One of the LF compensation and other is the HF compensation. That is the low frequency compensation and high frequency compensation. The two type of the compensation is done and in the probes. So the probes that have only the adjustment, it is the low frequency that have only one adjustment. अगर एक ही adjustment है, that is the LF compensation that is adjusted. Sometimes the HF compensation may be adjusted in the factory. So these are the things. Now let us discuss about the different type of the probes. So different type of the probe. May the first one probe is at the in the last para you can see the first type of the probe is the current probes. So current probes is basically used. You know that the current we cannot measure directly. The circuit should be completed to measure the current. So here in this current probe, that circuit, internal circuit is present, which internal circuit is present, through that the current flows, and that is measured on the oscilloscope. So there is a current probe, then there is an active probe. So as the active probe means as the frequency rise, the standard passive probes becomes the less effective. High frequencies पे जो passive probes होती हैं, they becomes less effective because they are the resistive probes. But when the low frequencies पे high frequency पे they are ineffective. So passive probes. So we have to use the active probes. So as frequency rise, the standard passive probes becomes less effective, and the effect of the capacitance rises and the bandwidth is limited. So actually में जैसे frequency बढ़ती है, तो क्योंकि every coil, every wire works as a capacitor. Wherever there are two wires are running in parallel, they behave as a capacitor. So if they are behaving as a capacitor, then if frequency will increase, you know that the capacitive reactance is represented by 1/2 pi Fc. So as the frequency will increase, the capacitive reactance will decrease. So there is the chance of the short circuit between the two wires. So that's why at high frequencies, if capacitive reactance decreases, so there will be a chances of the short circuit. So we have to modify such kind of the probes. So we cannot use the same probe for the low frequency as well as for the high frequency purpose. So that's why for the high frequency, there is a special type of the probes are made, which are the active probes. Then another, there is a differential scope probes. So in that case, sometimes it may be necessary to measure the differential signals. Means differential signal means the two signals we have to measure, compare two signals we have to compare at a time. So for that purpose, we are using differential signals. So low level audio, high disk signals, and many more instances there is a differential signals are these. तो आपने देखा होगा जो ऑडियो सिग्नल्स होते हैं, ऑडियो सिग्नल्स आर ऑलवेज हैव द two wires, positive and the negative. So always we get this differential voltage for the audio signals. So for that purpose we need the differential probes in which it have the provision of detecting the two differential voltages. So that's why this is the special type of the probes we are using. And at last you can see in the bottom there is a high voltage probe. So you can go through this text very in a simplified way, it is written. And the last there is a high voltage probe. High voltage probe, so most standard oscilloscope voltage probes, most standard, that is the most standard oscilloscope voltage probes like the X1 or the X10 are the only specified for operation up to the voltages of few hundreds volts at most. For operation higher than the proper high voltage probes, with especially insulated probes is required. It will also set up. It also will set the step down the voltage for the input to the scope so that the test instrument is not damaged by the high voltage. The often voltage probes are X50 and X100, which is not basically used in our laboratory. Now the next is your special purpose oscilloscopes, which we were discussing. I told you that we study the special purpose oscilloscope. The first one is the dual beam oscilloscopes. So as the name suggests, dual beam. So basically this kind of the oscilloscope consists of dual beam. दो beam हम use करते हैं, तो there are two electron guns we are using in this kind of the CRT. दो electron gun दो अलग-अलग beam को transmit करेंगे. और इस केस में हमारे पास में दो vertical deflection plates होती हैं. We are using the two set of the vertical deflection plates and the one set of the horizontal deflection plate. So both since two beams we are using, as the name suggests, this is the dual beam, means two beams are there. So two beams are used to represent the two signals simultaneously on the screen of the CRT. So when two signals are we can watch, we can see the two signals on the simultaneously on the face of the screen. So for this purpose, in this type of the dual beam CRO, we are using the two electron guns, and two different two separate two electron guns and two separate two electron gun and the two separate you can see the two separate vertical deflection plates. One signal is applied on the first vertical deflection plate, another signal is applied on the second vertical deflection plate, and we use the common one horizontal deflection plate for both of them here in the dual beam oscilloscope, as you can see in the block diagram also. So there are the signal A and the signal B. So signal A, the signal A means we are applying a signal A which we want to measure at the signal A. Then it is pre-amplified and attenuator are provided. Then delay line is there. The purpose of the delay line is to synchronize with the time-based generator. जो हम स्वीप सिग्नल अप्लाइड करते हैं हॉरिजॉन्टल डिफ्लेक्शन प्लेट पे, उसके साथ में मेरा इनपुट सिग्नल सिंक्रोनाइज होना चाहिए, दोनों सिग्नल साइमल्टेनियसली अप्लाई होना चाहिए, तभी वो ट्रेस बनेगा स्क्रीन के ऊपर. तो दोनों को साइमल्टेनियस अप्लाई करने के लिए बेसिकली वी यूज डिले लाइन. पर्पस ऑफ द डिले लाइन टू डिले दी इनपुट सिग्नल. तब तक डिले करना है जब तक कि वो स्वीप सिग्नल ना आ जाए वहां से. तो जब both that is internally calculated कि how much time the sweep signal is taking to reach at the horizontal diffraction plate. So up to that time the input signal is delayed. So that's why delay line we are using here. And after that it is applied to the main vertical amplifier. Similarly, the signal B is also applied through the delay line to the main vertical amplifier. And at the bottom side you can see there is a trigger circuit. And the trigger can be taken from the different sources. The trigger can be taken from the signal A, trigger can be taken from the signal B, and trigger can be taken from the external source, and the trigger can be taken from the line also, line voltage also. There are 4 sources are there for the trigger signal. Then trigger signal is applied to the sweep generator. Sweep generator generates the sawtooth waveform, and then it is applied to the horizontal amplifier, and further it is given to the horizontal deflection plate. So this is the way how the dual beam CRO is working, and we are presenting the both the signals together on the face of the screen. Next is your dual trace oscilloscope. Dual trace, as the name suggests, is also used for the same purpose, to trace the two signals on the same face of the screen, but here single beam is used. We are not using the two beams. Only single electron gun is there in this dual trace oscilloscope, while in dual beam we are using two electron guns, two separate beams to trace the two signals simultaneously. But in dual trace oscilloscope, single beam is used to trace the two signals simultaneously. Here also we are applying two signals at the input, and we are measuring or we are watching the two signals simultaneously on the face of the screen, but single beam is used for that purpose. Understood? We are using single beam for this purpose. So what is happening here in this case, as you can see in the diagram, we are using a single vertical amplifier. Here we are not using the two vertical deflection plate, we are using single vertical deflection plate and the single horizontal deflection plate, and still we are able to measure or to watch the two signals simultaneously on the face of the screen. How is it possible? Basically this thing is being done with the alternate sweep. Just you try to understand. For first sweep, जैसे आपने देखा होगा कि एक स्वीप सिग्नल हॉरिजॉन्टल जो सॉटूथ वेवफॉर्म का जो एक पीरियड है सॉटूथ वेवफॉर्म का, वो यूज होता है एक साइकिल को ट्रेस करने के लिए. फिर जब सेकंड पीरियड आता है सॉटूथ वेवफॉर्म को, वो दूसरे पीरियड को ट्रेस करता है इनपुट सिग्नल के. तो व्हाट वी आर डूइंग कि यहाँ पे अल्टरनेट स्वीप यूज होता है दोनों बीम्स को, दोनों इनपुट सिग्नल को ट्रेस करने के लिए. यानी कि पहला जो स्वीप का जो पीरियड है, जो पहला जो स्वीप साइकिल है वो यूज होगा पहले इनपुट सिग्नल को ट्रेस करने के लिए, और सेकंड स्वीप पीरियड विल बी यूज्ड फॉर टू ट्रेस द सेकंड इनपुट सिग्नल. फिर थर्ड पीरियड ऑफ द स्वीप सिग्नल इज यूज्ड टू ट्रेस द फर्स्ट इनपुट सिग्नल, एंड द फोर्थ वन इज यूज्ड टू द ट्रेस द सेकंड इनपुट सिग्नल. मींस अल्टरनेटिवली the alternate period of the sweep signal trace the alternate input signals. यानी alternatively we are tracing the input, both the input signals on the face of the screen through alternate sweep. पहले स्वीप ने पहले सिग्नल को ट्रेस किया, दूसरे स्वीप का मतलब जो स्वीप सिग्नल का जो पहला पीरियड है, पहले पीरियड ने फर्स्ट सिग्नल को ट्रेस किया, फर्स्ट सिग्नल के फर्स्ट पीरियड को ट्रेस किया, फर्स्ट साइकिल को ट्रेस किया, दूसरे स्वीप पीरियड ने सेकंड सिग्नल के फर्स्ट साइकिल को ट्रेस किया, थर्ड स्वीप पीरियड ने फर्स्ट सिग्नल के साइकिल को ट्रेस किया, फोर्थ स्वीप पीरियड ने सेकंड सिग्नल के साइकिल को ट्रेस किया। ऐसे ही अल्टरनेट जो स्वीप पीरियड्स हैं वो अल्टरनेटिवली दोनों इनपुट सिग्नल्स के साइकिल को ट्रेस करते हैं। So this is the method we are using in dual trace oscilloscope. Right. In our lab, you will see that we are having the DSO, digital storage oscilloscope. These are dual trace only. Okay, we are using. So as you can see in the diagram, we have the two channels, channel A and channel B. Both are having the preamplifiers and both are having the delay lines, but simultaneously so sorry for interrupt. So the same thing I was discussing, the alternate position पे उसको signal को trace करते हैं, and there is a provision of the switch. A switch is given for that purpose. As you can see, that is working in the XY mode, and sweep generator is also switch. तो ये automatically generate होता, automatically switch होता है. That is not being manually, it is not being handled. Automatically, alternatively, it is being switched to trace the both the input signals together. This is the way how it is traced. It is shown here for the channel A and channel B. You can see the channel A is being traced by the first period of the sweep signal, and the channel B is being traced by the second sweep period, second sweep signal, and again the channel A is traced by the third sweep signal. तो एक ही स्वीप सिग्नल से और एक ही स्वीप सिग्नल के जो पीरियड्स हैं उससे अलग अलग चैनल्स को हम अल्टरनेटिवली ट्रेस कर रहे हैं. You can see that 100 microsecond is given for the channel A, 50 microsecond is the falling time, and that should be as minimum as possible. इस पीरियड में कोई ट्रेस नहीं होता है. इस पीरियड में तो बीम मेरा जो राइट साइड से इमीडिएटली लेफ्ट साइड में, स्क्रीन के लेफ्ट साइड में पहुंचना होता है इमीडिएटली, बट जो ट्रेसिंग होता है वो लीनियरली इंक्रीजिंग वोल्टेज से ट्रेसिंग होता है. तो एज यू कैन सी इन द वेवफॉर्म आल्सो. Now next is your next oscilloscope is dual trace oscilloscope 0 to 15 megahertz. So the purpose of this is that since as the name suggests, this is the dual trace. So we can again start. That is the dual trace oscilloscope. The procedure we have already. सॉरी फॉर डिले, बीच में फोन आ गया था, तो स्टूडेंट्स के फोन आते रहते हैं, आई डोंट नो व्हाई. So dual trace oscilloscope, 0 to 15 megahertz. You can go through this. The same thing is explained here also. So you can go through this. So there is another is the sampling oscilloscope. We can see. I think we will keep up to here only. आज हम इतना ही रखते हैं. बाकी का जो portion है वो फिर next class में हम discuss करेंगे. I'm taking attendance right now. Very less students have joined in the second session. I don't know why. So the rest of the things we will discuss in the next class. Okay. Chalo. Okay. Bye to you all. Is it okay?
Yes, sir.
ठीक है.